Okay, so I think we can get started. Welcome to another Gazebo community meeting. Today we have a very special one where we got all of our summer interns together to present their work that they've done during the summer. Some of them are not here and they sent us videos because everybody has started classes and it was hard to find a time that fit for everybody. But some of them are going to do live presentations here for us. So that's very exciting. We had both interns directly with Open Robotics and some interns through the Google Summer of Code. So just to start with some, just the agenda like we always have. So it's about 5 minutes of announcements. Then it may end up being a little bit more than 40 minutes. We'll see how long each one takes to make their presentations. And then we're going to skip news for this week to give the interns more time. And then if anyone wants to discuss anything else, if we have time in the end, we can talk about it. So let's jump right into the announcements. So today is Garden Code Freeze. If people are following the release steps that we have here on this ticket, we are right at the end of feature freeze and we're about to enter code freeze. We're starting to make pre-releases for all of the libraries. And we have started a t-shirt campaign, which I forgot to add to the announcements. So, you should get a garden t-shirt. It's already available. The logo is public. So if you want to, wear the Gazebo branded stuff, this is your chance. And tomorrow we're going to be starting the tutorial party. Stay tuned for that. There will be an announcement. And after code freeze, this is the time to fix documentation, iron out any critical bugs that we find in the code base. We had a whole month of feature freeze where we were only fixing bugs and not developing new features. And now it's just time for critical bugs, making releases, fixing documentation, and that kind of stuff. So, and we really count with the help of the community for this. As always, we hold a tutorial party. As previous releases, we are going to be handing out t-shirts for the people who help us the most with the tutorial party. So be sure to join and help us review some tutorials. This time, we're going to have a slightly different process. It's not going to be a spreadsheet like we've done in the past. It's going to be something much more elaborate and much easier for everybody to join. So I hope this will help everybody, help us test the release a little bit better. So we've also had some releases since the last meeting for Citadel and Fortress. So if people are using our teleop GUI, you will notice that now it has vertical control as well. Before it was only 2D. Now you have a third dimension there that you can use to control a drone, for example. And you all have the three options of using buttons or the keyboard or sliders to control your robots in simulation. Also, we have a bunch of new hotkeys for the plugin menu, and Hao-Yuan is going to be talking more about this in his presentation today. We also have the standardized notification bar for plugins to show information to the users in a standardized way. A bunch of new math classes on Gazebo Math, so check it out if you're interested in using like polynomial, region, scalar fields, things like that. It's possible to make kinematic loops only for programmatically right now, but we are working towards full support for kinematic loops. And there are new widgets for generic like pose and vector and color, and you're going to hear more about this during some of the presentations too. So these are some of the highlights of the releases that we had the past month. And finally, if you haven't yet, this is the last day for you to vote on the name for the next release. So we always open the vote for the community. You have some options here to rank the names that you prefer. And we're going to be announcing the winner in the next community meeting, where our team is going to come and present all of the new features in Gazebo Garden and and the name for Gazebo H. So be sure to vote there. Another thing that I wanted to tell everybody, this is my last time hosting one of these meetings. I'm transitioning to a new job starting next month. So other people are going to be here. I'm planning to stay, continue being a part of the community. I'm still going to be around. I'm still going to be around on GitHub and stuff, but I'm not going to be actively developing Gazebo anymore. So it's been great, and hope to see everybody around in the robotics world. So let's jump into the presentations. So let's start with our interns. We have 3 who will be doing it live, and we have 3 recorded videos here. So we're going to start with the live ones. So Onur, it's your turn. So I'm going to stop sharing my screen, and whenever you're ready, you're good to go.
Okay, let me share my screen. I think you can see my screen, right? Without any problem.
Yeah, looks good.
Okay. So hello, everyone. I will talk about our Google Summer of Code project named Improving Gazebo Mesh Format Support. And my mentors were Alex and Luca. Luca was an official mentor, but he helped me and guided me a lot, so I added him as well. And you can find the meta ticket in this, like I added a link, and also you can enter that to GitHub. So the outline will be, for this presentation, will be, first I will talk about the initial state of the mesh loading system and our project statement. Then I will move on to analysis of our approach and some statistic about implementation. Then finally, the current version of the mesh loading system and future work that needs to be done to finalize everything. So I want to first give you the some overview of the mesh loading pipeline, the initial version. So we have usually some inputs that might come from STF files or might be a drag and drop. These inputs include meshes, and through some internal codes, these mesh files move to Mesh Manager, and Mesh Manager use basically these 3 loaders to load some cool meshes that basically do cool stuff, like dancing robots or doing different activities. And with that in our mind, I would like to talk about our project statement. We wanted to, at the end of the project, we wanted to load GLTF or FBX meshes. And to do that, the scope includes evaluating alternative open source libraries such as Assimp to determine the best possible path. So with that, I'm started with the Assimp for the external mesh loading option, and writing our own as a second option. And for the second option, for writing our own ways, we only decided to write FBX and GLTF. In the case of Assimp or any other additional any other external library, the class diagram should you can see the class diagram, and in the class diagram you see some Assimp loader, something new, and this Assimp loader use some function name Assimp to Gazebo that basically converts the Assimp mesh files into Gazebo mesh format. And in the other way, it's basically the same with the other legacy loaders. So in that sense, both of the options change the mesh manager a little bit. And we go over weight in each option, and each option has some pros and cons. I mean, if you use Assimp, we have more supported formats, and Assimp has like huge user base with more than 10 years of development history. But we also know that if you use some external library, then we lose some control over it. And probably if something bad happens with the external library, it affects everything rather than just affecting the specific loader. So, but with all of these in our mind, we said, let's analyze Assimp. And we start to analyze it. We put some metrics, such as how Assimp maps the scene, which includes mesh, animation materials, what new file formats we can support using Assimp, what new dependencies brought to the Gazebo, and of course, the license, whether we can use it or not. And you can actually see all of these and more detailed version in the comparison report. But I would like to go over the just three important parts of it. So the speed memory and the memory leaks. So to create these graphs, basically, or figures or tables, we basically load a bunch of meshes through Assimp, and we use chronostatic clock and heap track to measure these. I mean, chronostatic clock for speed and heap track for memory. And then we basically created this average report. And as you can see, Assimp is not that bad. Actually, it's better than our default ones. And we have more detailed of these analysis in the comparison report. We also use some sanitizers to check whether any problem we have with the Assimp loader, and we don't have, so they didn't throw any error. Finally, we check some cyclomatic complexity of the Assimp loader and the other loaders. So as you can see, Assimp loader has like a lower cyclomatic complexity than the other loaders, and even the Assimp Collada loader, basically the internal loader of the Assimp, has lower complexity than the Collada. So with all of these results, we said that Assimp is good to go, and we continue to develop it and use it for the mesh loading system. So in the current state, we support GLTF and FBX. We also support skeletons and animations, but our approach still in experimental and requires GZ mesh force Assimp flag to be set true. If you set this true, then all the mesh files you are going to load to Gazebo will use the Assimp loader. Otherwise, it will use the legacy loaders. And for the future work, we have still some problems about actors, and I am still actively working on it. And there are some additional work for the materials. But if we, I think, finish these two, then we can finally deprecate the legacy loaders and use the Assimp for everything. So I would like to thank Alex and Luca again for their guidance, help, and support during the project. And that's basically it. Thank you for listening.
Thank you, Anur. That was great. In interest of time, I'm going to move on with the next student, and then in the end, we can have questions for all of you. So, Hao Yuan, it's your turn. Go ahead.
Thank you. Let's see. Where is this? Can you see it?
Yeah. Mm-hmm.
Okay, so today I'm glad to present you with 3 new features. The first one is the search menu update, which Louis just mentioned. So in this update, we are adding the new keyboard shortcut to the search plugins search menu on the top right corner. So here is a GIF of the full demonstration. We can use the / key to open the plugin search menu, use the arrow key up and down to navigate through the list. And notice here, if you add in the second plugin, the previous text will be auto-highlight. This is convenient for the users to add another plugins. So the second feature I would like to introduce is the common widget. This is a feature mostly for the, plugin developers. This helps them to write consistent styles for front-end coded with less front-end code and less debugging. So here we are introducing 4 new common widgets: GZ pose, GZ color, plot icon, and vectors. Notice that they all have different customized presets, so they can be set differently. For example, for GZ vector, we can set a unit to different strings. Here, the default value is meters, but we can also set it to Tesla, to voltage, to anything else. We can also set it to set read only to false. Then the value here will be writable input texts. And the biggest advantage for common widgets is to implement the same front-end widget with less code. So here on the left side, you can see with common widget, it only takes 8 lines to implement. But on the right side, without the common widget, it takes 74 lines to implement. So the last feature I would like to introduce is the test coverage. Well, the test coverage is how many code, the percentage of the code that is covered by our test. So my job here is to add the pipeline of the ignore files. This means we can now ignore files that is rendered from other sources. So here we are increasing 6 repositories test coverage. We remove over 6,000 lines of misses tests previously. Here are the statistics, and on the top left, you can see an example of the ignore files. This ignore file is very easy to use and very convenient for feature expansion. If there's a more web code, it should be ignored. Okay, lastly, thanks Open Robotics for giving me the opportunity for the internship, and special thanks to Luis and Jen for the mandatory. Good luck on your new opportunity job, Luis.
Thank you, Haiwan. Great presentation. Okay, so who's next now is Harsh. Are you ready to start?
Yeah, sure. I'll just present my screen. So this was my project Gazebo package creation tools. This was done under GShock. So my mentors were Arju, official mentor, and Luis also helped me through the process. So thanks a lot to both of them. Now moving through what was the problem that I was trying to solve. The problem I was trying to solve is like this: Gazebo plus CMake plus new user equals confusion. So explaining it in more details, basically, whenever there was no package creation tool or template repository present for Gazebo, basically. So basically, if you want to create a new Gazebo package, you have to go to GitHub, see some of the repositories that have already implemented Gazebo packages like LRA UV or Sapti challenge packages, and then you have to create a repository using a package using that. And also the problem with them was there were a lot of things in them, like they have like CMake list files that are 150 lines of code. So for a new user or a not that good user, it would get almost impossible to know what features are essential to create a new package, basically. So there was no template repository present, neither was there a package creation tool like ROS2 package create, where you can simply create a template package. Also, the second problem was sourcing, installing and sourcing plugins and files, etc. was a long process. Basically, you have to first install the plugins, and then you have to source them using colcon.package or .sh file, etc. So this can also take some time even for a good user, and for new users, this can get confusing also. So here comes the solution: two things: ignition package create subcommand and CMake macros. So I'll get over them one by one. So ignition package create subcommand. It's simply a subcommand like ROS2 package creates a template repository for ROS. In similar way, ignition package creates template repositories for Gazebo. Basically, it is ignition package create for older versions. For newer version, it will be GZ package create. So this is what it does. So how its work is simply uses embedded Ruby files to create various templates, and based on the user's arguments, the template files are edited, and then you get a template package, basically. The location currently it is located in a new repository named ZZ package create. It's a separate repository. So now moving forward, what are the options that it currently offers? So if you go ignition package create /h, then you will see all the options that is offered. Currently it takes the name, and then one option is init with example system. Basically, if you select this system, it would give you a lot of examples pre-installed and sourced. Basically, a example plugin, an example executable, and a few example worlds and models. So a user, and that all of them will be installed and also sourced. So a user could simply go and like test Gazebo basically using this. Next is build type. Currently, it supports two build types: Amnet CMake and plain CMake. As the name suggests, if you use Amnet CMake, it would have Amnet macros and Amnet dependencies. If you use plain CMake, it won't have. Next is export type. This is interesting. Like currently, it's supposed two export types: Colcon and plain CMake. So basically, if you select the Colcon export type, then the parts that are being exported, parts of plugins, messages, worlds, etc., then those will be exported using Colcon.pkg and hooks file. But if you select plain CMake, then it would be exported using .sh file simply. So that's the difference. Next is ignition dependencies. If you select them, then the common ignition dependencies, like the package will depend on common ignition Gazebo packages like Gazebo Sim and Gazebo CMake and Gazebo tools, etc. This link. And next is Gazebo version. You can simply specify the version for which you want dependencies to be. Moving forward, CMake macros. So currently there are five major macros and then some minor macros to support them. So what are these macros? Ignition add resources, ignition add plugins, ignition add executables, ignition add messages, and ignition environment. So I'll get over them one by one. what ignition add resources do, you'll simply, the input is simply the folder. You'll give the directory name, and it would install the directory and source it part as a resource. Next is ignition add plugins. It would do also similar thing. If you give us folder, it would go inside that folder and select all the plugins inside that folder. It would install them. You have options to add options to add link libraries and all that, and based on that it will install them, and then it would source its part out. The same for ignition add executables and messages. And what ignition environment hook will do, basically this macros does that sourcing the part out thing, that it would take the parts from all 4 macros, and then it would create colcon package and hooks file if it's a colcon dependent package, or it would create .sh file for a non-colcon dependent package. So basically, in short, this file basically does 2 things. First of all, it reduces the amount of steps you have to do to add basically multiple plugins or multiple resources or models. It reduces a step to do that, and also it parallelly exports the variables of various plugins and worlds, etc. So that was this. As you can see, like in 10 lines of code, we have installed and at the same time exported the parts of multiple worlds, models, plugins, examples, etc. So this is what it does. Now I'll show you a short demo of it working. So this is a empty package. You can see I'll just go ignition package create. I've written a sample code. I'll run this, and as you can see, a test package has been created. I'll just show you the insights of the package. So as you can see, it already has a CMake list which has dependencies, and it has all dependencies on common ignition packages. It has worlds, models all installed using this my macros. And as you can see, as you can see here is the executable plugins model. So basically, it has a lot of examples and codes and it has also comments for explaining the examples to a new user. And you can simply now go back to the original folder. You can simply colcon build it. So as you can see, a colcon.package and colcon.package and hooks folder have been created when you colcon build this. So now I'll simply source the now everything is sourced, so I can run the example like this random points, and I can also just copy the name of the file. So if I want to run the world, I can run this. As you can see, the world has been launched, and also the plugin Hello World is also working. So if you go, you can see the world also working and the plugins also working. So a new user can simply test all the features and know how, and he does not have to know how to source a plugin, or basically how to install and source a plugin executable, etc. So that was the project. Thanks. I again like to thank Luis and Arzu for helping me throughout the project. Thank you.
Awesome, cool. Thank you, Harsh. Okay, now we're going for our pre-recorded presentation. So the first one is going to be Tianyu with Space Ross. So let me share that.
Hi everyone, my name is Tianyu Li. I am going to present my summer internship project, which is Space ROS simulations in Gazebo. A very brief intro to Space ROS. Space ROS is a variant of ROS2 which specializes in space applications. It could provide a design that meets space mission standards and certifications. Some important features include focusing on source code quality and integrating more code analysis tools. Sandboxing language features such as memory allocation and exceptions. Of course, there will be more space-specific theme modules like packages, plugins, and messages. My projects here show two space-themed demos running in the Space ROS environment with Gazebo. The two demos showcase Space ROS and provide examples to help future developers get started. The Curiosity rover is a Mars rover that is in service since 2012. NASA made the 3D model of the rover open source, and it was turned into a ROS project. Since Space ROS is spaced out of ROS 2, a major step is to port the project and also some missing parts from ROS 1 to the Space ROS environment, as well as from the Gazebo Classic to Ignition Gazebo. The first demo is a simulation of the Curiosity rover driving on the Martian surface. Okay, here we have the rover just landed on the Martian surface. Here is a big chunk of Martian surface with hues and bumps that's adapted from the ROS 1 version. Let's now go back to the rover. There are some moving parts on the rover. For example, the mast cam can move with 3 joints. The robot arm that carries scientific payload can also move. Here shows the suspension arm compliant to the surface when driving on uneven terrain. Last but not least, the Ackerman steering. The next demo I did was for Canadarm2. Canadarm2 is a huge 7 degrees freedom robot arm on the International Space Station, in service since 2001. It mainly helps with moving supplies, repairing, and docking. It has 2 identical latching end effectors, so it looks somewhat symmetrical. Besides using realistic data to create the URDF for the model, I also created meshes and textures to make it look more realistic. In the simulation, as you can see from the picture on the left here, I also added a big Earth mesh and a small segment of the ISS to make it look more realistic. Let's now see the actual demo. Here's a small segment of the ISS, which is the Columbus service module. And here is the Canadarm2 latching to a port on the Columbus service module. And the structure looks pretty symmetrical in the initial configuration. And the background is a big Earth mesh. The Canadarm itself has a logo on each of the segment and a blue strip on one of the link. Both end effectors can be attached to the ISS. Now let's move the Canadarm a little bit. It is controlled by a customized joint effort position controller and controlled through the GZ control package. The arm is super heavy with large inertia, so the movement will be pretty slow. I'm going to speed up the process so that the movement is more clear. Here are some examples of the arm moving. And that's it. Thank you very much for watching.
Okay, that was Tianyu. And let's go to Sumed.
Hi, Gazebo community. This is Sumedh Koppula, one of the software engineering intern at Open Robotics. So this summer, I have been working on Turtlebot 4 and few other tasks. In this session, I'll be giving an overview of Turtlebot 4 along with few features I worked on, and I'll be presenting few interesting projects that will be helpful for new ROS2 and Gazebo users. To introduce, Turtlebot 4 comes in two different flavors, standard and light version. Both are equipped with Raspberry Pi 4 running on ROS2 Galactic. Moreover, it comes with iRobot Create 3 mobile base. And talking about sensors, it is equipped with AI spatial stereo camera along with a 2D LiDAR. In case of standard variant, we even provide HMI display for user interactions. So this next generation research and educational robot is equipped with course material, including lectures, projects, and sample tests. So going with features. So even before discussing this HMI user slot feature, let me discuss about how one can publish Turtlebot 4 command velocity topic from Gazebo GUI. So as you can see in the image, you can feed linear and angular velocities onto GUI, and one can navigate robot using either arrows or from keyboard by enabling the slider. And similarly, if you decide to view camera topics, you can even view Turtlebot 4's camera topics from Ignition Gazebo GUI. That's interesting, right? So now let me discuss about how this HMI user program slot feature will be helpful for research facilities. So the problem with the previous generation Turtlebots is that it's reusability. Let's say if a lab consists of 40 students, on an ideal case, the lab should be accommodated with 40 Turtlebots for experimental use, which is costly and needs heavy investment. So for that reason, we have come up with a feasible solution where users can reconfigure their launch from the designated user slots. With this, 4 users can share a single robot for their purpose, wherein mitigating the number of Turtlebots required to 10. So let me show you a quick demo of what I am trying to speak. So here you can see that I have configured 4 user slots by running a program manager package, where here the first slot is configured to launch undog action. So once the button is pressed, the Turtlebot 4 undogs from its dock. And the second user program is configured in such a way that I'll be able to launch a motion planner with default goal values. So now the motion planner is being executed and the Turtlebot 4 is trying to reach the goal pose. So similarly, the third slot is configured to launch TurtleSim, and the fourth slot is configured to launch TurtleSim teleop nodes. So I'll be able to show that for you people. So here on pressing user program 3, TurtleSim has been fired, and you can see the TurtleSim. And on the fourth user slot, you can see that teleop nodes have been fired. And you can see that you can operate from your keyboard. Yep. So now let me discuss about some useful classroom ready projects which I've been working this summer. So these projects are simulator on Gazebo Ignition using Turtlebot 4. I was working on building a motion planner that will be helpful for new ROS2 and Gazebo users to understand how one can integrate LiDAR and perform navigation based on data received, and how one can implement extended Kalman filter for state estimation of 2D pose. So what I was trying to do is, like, overall, I was addressing how one can implement and simulate a motion planner with obstacle avoidance from scratch. So here I'm trying to use a simple bug to motion planning algorithm. So I'll try to explain you people the algorithm in a nutshell. So initially we calculate the slope between start and goal pose. So here you can see that the dotted line as in the figure is nothing but the slope line. Now our Turtlebot 4 navigates from the start pose following along the slope line. And once an object or wall is sensed from the LiDAR, the Turtlebot switches its mode to follow the obstacle mode. And now the Turtlebot 4 tries to follow along the path of the wall. And then on the second hit with the slope line, the robot switches to follow along the slope line mode. So it re-switches to its back mode. And then it tries to follow along the slope line. And this continues until it reaches the goal. So it's a pretty simple algorithm. So here for state estimation, we have used external Kalman filter. So I'm not going in depth about how I implemented this. You can find the code in the repository. So here is the demo. So let me try to increase the speed. Yes. So here the Turtlebot 4 initially undocks from its dock and then tries to execute a motion planning algorithm. So once the motion planning algorithm is executed, it tries to go along the SD line. And once it detects the wall, it tries to switch its modes from the follow the slope line to wall follow mode. And it tries to continue to follow the wall. And once it reaches the second hit, it again tries to follow the SD line and then tries to follow the wall again. And it reaches the goal pose. Simple, right? But it gives an understanding to new ROS2 and Gazebo users on how to implement motion planning algorithms. So let me go with another classroom-ready projects. It's nothing but implementation of 3D object detection using MediaPipe and OpenCV. So this can be useful for people who are willing to learn about perception modules on how to integrate CV Bridge or how to integrate ROS2 and OpenCV and how one can use other computer vision APIs into their project. So in this module, I did use Google open source MediaPipe API for object detection and tracking using Turtlebot in Gazebo simulation. So there are many perception APIs like YOLO in the market. However, I did choose MediaPipe for a few reasons. So the reasons being its ease of integration and cross-platform usability, and it has got faster FPS on common hardware like Raspberry Pi 4. And I feel like it is easy to custom train object-run dataset with a custom classification. So what am I trying to do here is I'm trying to detect objects in 2D images and I'm estimating their poses through a machine learning model trained on object-run dataset. So I'll try to quickly show you a demo how this is implemented in Gazebo simulator. So here the Turtlebot 4 goes to the object location and it tries to detect the object using its object-run dataset. Here in the object-run dataset, I'm trying to feed multiple classes. So here, shoe is one type of class, which Turtlebot 4 is trying to detect. So you can see that the pose and object detection is being done. So yeah, so this is something which I was trying to discuss about, and you can try to custom train your machine learning model using your own object-run dataset. That's the advantage of using this API. So what I'm trying to do here is I'm trying to publish the pose and the object detected data via a topic. So these topics can be subscribed in your motion planner or any other application as per your business logic. So Yep. So this previous object detection implementation can also be performed using inbuilt bounding box camera sensor in Gazebo. So this feature is introduced in the month of July, and this update needs to be implemented using Gazebo Fortress. So you can simply modify your SDF file with a new bounding box camera sensor and configure the sensor parameters such as box type, camera, and topics. Let's say if you wanted 3D object detection, then you can mention your box type as 3D and few basic camera parameters and the topic in which you wanted to publish the data. So in this sensor, only models with label or annotated class will be visible by bounding box camera sensor, and unlabeled models will be considered as background. To assign a label to a model, we are using a label plugin in the SDF file. So you can even generate your own training set, and the complete details and tutorials are provided in this particular link. You can access that and you can try to experiment as you go. So, yep, that's it. This was my summer, and I was trying to learn a lot of stuff from Ignition Gazebo, and that was pretty helpful. I really thank Gazebo community for providing the open source simulator, which is really helpful for researchers and educational institutions. Thank you.
That was Sumedh. And last but not least, we'll go with Brian.
Hello, my name is Brian Schiff, and I'm one of the interns this past summer at Open Robotics. And today I'll be presenting some of the work I did, more notably my work on service introspection, or finally being able to take a look into what services are doing. Unfortunately, I'll be joining you today via a pre-recorded video because as this is playing, I'll be probably rushing to catch a flight to Toronto, where I go to school at U of T. So what is service introspection? Well, since ROS1 services were introduced back in about 2011, there's been no built-in tooling for being able to echo or record these services and to basically take a look at what they're doing. And on a more personal note, this is one of the reasons why we don't actually use services, or very minimally, at O Toronto, one of the design teams I'm a part of at U of T, where we build self-driving cars. So what are the features? Well, basically what happens is we publish the service events to a hidden topic, a new hidden topic. And these service event messages, of which there are 4 types for client sent, service received, service sent, and client received. So these 4 events are published out to this hidden topic, and they contain metadata about the event. So for example, the unique ID of the client, the timestamp, and so forth. And this enables some new features such as ROS2 service echo and recording of these services. One thing to keep in mind is that some users might not want to have all of this new runtime burden on their system. So we make this configurable at runtime, so you can turn on and off publishing these service events. And another nice thing about this is that it naturally supports actions, given that actions are built on services and topics. So all that sounds great. How do I opt in? Well, all you have to do, as per the current design, is to add a enable service introspection flag to your node when you initialize your node. This is subject to change. If you have strong feelings about it, leave a comment in the rep or on the meta ticket for this issue. So rep 2012, ROS2 number 1285. So I'll switch over to a quick demo. So I've put up 2, just taken the add to inst demo and then enabled the service introspection flag on each of them. So I'm going to run these. As you can see, it is indeed adding 2 ints, and I can run ROS2 service echo. So if we take a look here, we can see them grouped together by sequence number and unique ID. And then you get the response received, response sent, request received, request sent. So these are all for corresponding service events. So let's say we don't care about what's going on the server side, and we only care about what's happening on the client side. So we can set the parameter public service events on the server to false. Okay, and now if we take a look here, we only get the request sent and response received events that are coming from the client. And we can disable everything altogether by setting that false for the client as well. Set that to false. And we see that no introspection messages are being sent to the system at all. So let's enable both of these and move on to recording. So see if we can enable both of these. And here we go. Let's run ROS2 bag record add twins, and we're going to record it to a service introspection bag. Okay, that should be enough. I'm going to stop these two. Okay, I'm just run ROS2 bag info service introspection, and that tells us that we have a service event being recorded, the type, etc. We can even play it back into the system. And we see that ROS2 service echo picks up back on it. One thing to note is that playing back the service events only plays back the event message, but not the actual client request or the service response. That can be implemented depending, it's fairly trivial to do so from the what's currently available, and depending on how things go, we may or may not add support for that. However, playing back service responses is a bit more tricky. It doesn't necessarily make sense because it depends on the client request. Yeah, that is up to the user at this point. And if we get something with enough community support, then we might consider merging it in as a default tool. So implementation-wise, most of it is pretty irrelevant, except for the fact that most of it's done in RCL, meaning that most client libraries should get this new feature for free as long as they implement some things in the type support and etc. So in retrospect, I feel like what I did this summer was it can really be consolidated into doing a lot of plumbing. And the thing with plumbing is that it's usually kind of out of sight. But the thing is, if you go home and the plumbing isn't working, it kind of sucks, you know, like, and that's how it is with ROS. Like if you try to use ROS and the plumbing sucks, then it's not a great experience. But if you can improve the plumbing, it makes the developer experience a heck of a lot better. And that's one of the things that I hope I did this summer. And yeah, quick thank you to Louise and Open Robotics for the opportunity to present today, and to Jacob for being my mentor over the internship. And because I am not here, feel free to contact me via my email if necessary, or you can open up a issue on my Git repos that is weirdly pointed. Yeah, whatever floats your boat. But in any case, thank you for your time.
Cool. So that wraps it up. So we're open for questions now, even for the students who recorded videos. I think we have enough people here. We should be able to answer questions that people may have. Anything comes up? Remember, we had 5 presentations. There was the new mesh support on Gazebo, supporting GLTF with Assimp. There was the new GUI tools, the new package create command, space ROS, a bunch of Turtlebot stuff, and the ROS2 service introspection. Oh, while people are thinking of questions, I'm gonna share a link that I forgot to share earlier, which is our t-shirt campaign for Garden. So as you can see, we have an awesome logo as always for the upcoming release. And there's a link here where you can get your t-shirt, and the graphics for the logo are available here as well. And there are shirts with the black background, with the green background. You can get a pillow, you can get baby onesies. There's a bunch of options there for everybody. So if there are no questions, I can wrap it up. Let's do that then. Well, thank you, everybody. And next month, we're going to be back here for the Garden release presentations. So our team is going to be presenting all of the cool new features that are coming in Gazebo Garden with a brand new world, you know, like we've done for the past few releases. So you should definitely join us and check it out if you want to see the latest features. So see you all. Bye-bye.